everyone, welcome back. So we're going to go ahead and take care of Thursday's lecture. This is Chapter 1, Lesson 2. We're revisiting distance. So you already have your cutouts. If you picked them up already, here they are. If you haven't yet had a chance to pick them up, or if there aren't any more there by the time you get to them, please pause this video at the appropriate times to draw the figures in. When you're drawing these figures in, please make sure that you are using a straight edge and compass for these constructions so that way the lines are as straight and beautiful and perfect as possible. Since we're doing coordinate grids and graphs, you might also want to grab some graph paper so that you can draw on these as well. All right, just cutting these out here. There are two titles for you on this particular cutout. There's the large title for your notes. There's the small print title for your table of contents. And there is also the date this time. I thought I would try to be fancy for you and go ahead and put the date so you can use that on your notes as well. All right, so we have got 5 different cutouts, 2 titles, a date, and 2 graphs. Let's go ahead and update our table of contents. I know I'm zoomed out really far. It's because we're not really seeing much of anything. We're just grabbing there we go. That was the title, the one that matches the title that is under the La Feria logo. Gonna flip on over. So these are the notes from yesterday. Go ahead and leave yourself a KWL for that lesson. And we're gonna get set up for our notes. Go ahead and pause the video now so that way you can get the lesson title and the objectives. All right, so we have our notes set up and ready to go. I'd like to start off with a reminder. I'm going to zoom in here so that we can see what's going on. What's going on? I'm all by myself today, trying to make this recording as fun and interesting for you guys as possible. There we are. Okay, so as a reminder, we have done the distance formula before, but we want to go ahead and just review it and rewrite it to make sure that we know what that formula is. Here's that distance formula. The square root of, and then a whole lot of craziness. The craziness is 2 coordinates, the x-coordinates from 2 points, x2 and x1. You're going to subtract those and square them. And you're going to add that to the same thing, but you're going to do it with the y-coordinates. Subtract them, and then take the square of that result. And when you're all done, you're going to take the square root of that. Hopefully none of that is brand new. Let's go ahead and kick this off with an example. Oh, where'd my little graphic go? Oh, it was hiding. All right, you want to find the graphic that has numbers on it. There you go. And we're going to calculate the distance. Calculate the distance. We need to select one of these 2 points to be our x1, y1. I'm going to go ahead and select this top one, but the choice really is yours. You can select whichever one you want. Going to highly recommend that when you start using these formulas, you always rewrite the formula that you're using, just so that you can keep track of what you're doing. All right, now we're going to substitute in. Here's x2. Here's x1, here's y2, here's y1. Okay, gonna change that double negative into a positive. and going to do this subtraction. Right, going to do this addition right in here, and this squaring. Let me scoot that over. Just realized that it wasn't completely visible, sorry. Gonna square that, and I end up with the square root of 36 plus 36. When I add those together, I'm gonna get the square root of 72, but I can't leave it this way. I have to reduce it. And so please recall that this is Chapter 0, Lesson 9 information, reducing radicals, or simplifying radicals, rather. Right, so I'm going to go ahead and do that process here. I need to find two things that when multiplied together give me 72, one of which is a perfect square. I'm going to go ahead and list out the factor pairs of 72. I have 1 times 72, 2 times 36, and I'm going to stop right here because 36 is a perfect square. And so now that I have found that perfect square, I'm going to rewrite 72 as these two factors, these two numbers that multiply together. So 72 becomes 2 times 36. Using the product property of radicals, I can break this single radical into two separate ones. And the reason I want to do that is because I know what the square root of 36 is. The square root of 36 is just the whole number 6. The square root of 36 is 6, just 6. This looks odd because in mathematics we like to write the whole numbers first as coefficients and everything else after, and so this would be our final distance. Nothing new, seems all right, but I want to add one more level of complexity for you, and that is to do the same thing but dealing with a construction. So if you'll please come down here to the example, next example space, and I'd like you to glue in the final graphic for today. There it is, and I'm going to take some time right now to make sure it's glued in nice and strong and straight, no bumps today, because we are doing a construction. So I hope that you've gotten a protractor and compass. I have not, so give me a second. I'm going to go get one. Rip, I was not prepared. All right, so we want to find the distance and use it to confirm congruence. So we are going to construct a congruent line segment and use the distance formula to confirm congruence. All right, there it is. So in order to construct a congruent line segment, please recall that this construction, put it over here, the construction of a congruent line segment was way back. Hang on, I gotta flip. Flippy, flippy, flippy. Where are my congruent segments? Here it is, way back, Chapter 1, Lesson 1A, Construction of Congruent Segments. So I'm just writing that code there. That's where you can find the directions. All right, I'm going to go ahead and make these endpoints a little easier to see. Right there and right there. Pause the video now, go back to those notes, Chapter 1, Lesson 1A, and do the congruent segment construction. All right, welcome back. I'm going to go ahead and do that construction right now. The first step says that I need to draw a segment, or a line rather, that is longer than this. So I'm going to use my protractor just to get a quick measurement. It looks like if I start it, I'm going to put this the right, whoa, numbers wrong, rip. If I start at 1, I need to go well past 4.5 to make this thing be longer than my current segment. So I'm going to come down here and I'm going to try to find a space that will do it. Here we go. It looks like if I start way down here on this point, and you know what, I'm going to go ahead and cross it. I'm going to start at this point and I'm going to go all the way to this one. And I know it's going to end up looking like it's on top of itself, but hopefully that'll be okay. Alright, so there it is, and I want to start right here. So I'm going to put my endpoint marking right there. Alright, the next step is to take your compass and to set the radius equal to the original segment that you're trying to copy. There it is. Okay? Now take your compass at this radius and set the center on the endpoint of where you want your segment to end up being copied to, and then mark your arc. Okay? So there, reconfirming that distance, and then reconfirming this distance. I'm going to tilt the compass a little bit so that you can see my marks. There we go. And it looks like this segment ends right about there. All right, I'm going to name these points so that way we can calculate the distance of each one. So we're going to start off, my original line segment is AB, and my new segment as CD. Please pause the video now and find the coordinates of all of these points. Welcome back. The coordinates for A are 1, 2, 3, 4, 5, negative, 1, 2, 3, 4, 5, 6, 7 in the positive. B is 1, 2, 3, 4, 5, 6, 7 in the positive. 1, 2, 3, 4, 5, 6, 7, 8. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9 in the negative. Okay, going to do the same thing for C. C is going to be 9 in the positive and 9 in the negative, and D ends up being 5 in the negative and 4 in the positive. All right, so there are our endpoints, and so we need to calculate the distance of each line. Pause the video now so that way you can work on those, and as soon as you come back, we shall work on it together. All right, welcome back. I'm going to find the distance between A and B, and I'm going to write really tiny here, and so I'm going to zoom in nice and tight so that you can see what I'm writing. I'm going to start off with the distance formula. Distance is x2 minus x1 squared plus y2 minus y1 squared, square root all of that mess. All right, so just substituting. Oh, I grabbed the x's. Okay. Well, I totally grabbed the y coordinates here for this first one instead of the x's, but honestly it'll be okay because these are both y's and these are both x's, and this symbol in here is addition. So hopefully when you did it, you substituted in the correct way. I kind of messed up, so I put my y coordinates here and my x coordinates here. Sorry about that. All right, here we're gonna continue with my example. 7 plus 9 is 16. This is going to be a negative 12. 16 squared is, I need to grab my calculator to help me out because I don't remember. So 16 squared is 256, and 12 squared is 144. And if I add those, I'm going to get 400, the square root of which is 20. All right, going to do the same thing for C and D. Go ahead and pause the video and do that now. When you come back, I will have it done. Welcome back. Here we go. We're going to do C and D. I'm going to actually write in this space just so that I have some more room. And hopefully I can get things in the right order this time because rip, I messed up the last one. Sorry. All right, here we go. Square root of x2, x1, y2, y1. All right, I got the right order this time. Okay, that's 14. This is 13. 14 squared is 196. I used a calculator for that. I'm not that smart. And 13 squared is 169, excuse me. Gonna add those two together, and I'm gonna end up with 365 under the radical, which I'm not going to bother calculating the square root of. Though you can use chapter 0 lesson 9 to simplify it. But remember that our whole goal on this one was to use the distance formula to confirm that we constructed these congruent segments properly. And if we look right here at the two big radicals, we notice they're not the same. So I probably did not do the segment construction as correctly as I was supposed to have. I'm just remeasuring it really quick. There's A to B. Okay, it looks like all my measurements are fine. I mean, it looks like it works out. So there's something going on between the numbers, and it's likely because this graph might not be perfectly square. If you notice, those squares are more like rectangles. And so that's probably what's causing this error. I think that if I were to take the square root of 65, I'd get something really close to 20. I'm going to go ahead and put it in the calculator just so that I can see some numbers that make a little more sense. And I get 19.1 when I put it in the calculator, which is only 1 unit or less than 1 unit away from 20. And so we'll call this one error by the graph that we're using not being perfectly square. So my apologies when I pulled this graphic, those little squares weren't perfect. But we'll look forward to using just regular old graph paper, I think, moving forward to make sure that this setup works. But that is the construction technique according to my compass. These two line segments are congruent. They have the same measure. We use the same distance, the same compass radius. But according to our numbers, and I think it's because, again, the grid lines don't match up, we've got some discrepancy with the numbers, but not by too much. All right, so there is distance revisited and an example of how you would use the distance formula to confirm that you did in fact have congruent line segments. Thanks and good luck on your homework. We'll see you Friday.